In this video, we will be looking at some quadratic application problems related to both standard and factored form. So let's start with an example where we are given the equation to model this scenario. The profit made from selling fidget spinners can be modeled by the equation P equals negative 0.2x squared plus 2.4x minus 2.2, where P represents the profit in thousands and X represents the number of fidget spinners produced in thousands. Alright, so how many fidget spinners must be sold to break even? Now, let's note that to break even means that the profit is zero, so you're not losing money or making money. If I were to start with just a little sketch to represent this scenario, we know the parabola is opening down, and we know the y-intercept is negative 0.2. So I'm just going to put a little x and p axis. So I'm going to draw my y-intercept below the origin, and then here's my parabola opening down. There's my scenario here. I'm not going to put anything in the negative x's because it doesn't make sense to sell a negative number of fidget spinners. It's not an accurate sketch, but it's going to guide me through the follow-up questions. So if I want my profit to be 0, this is where my profit is 0. So we are looking for the zeros or the x-intercepts. And even without the visual, if I know that the profit has to be 0, I'm going to replace P with 0. And then we are left with solving for x, which means solving this quadratic equation. Well, I'm not a fan of that negative 0.2, so I'm going to see if I can do a GCF of negative 0.2. I'm going to try dividing each coefficient by negative 0.2, and it works. So I'm going to do that GCF first to make my numbers a little more manageable. So 2.4 divided by negative 0.2 is negative 12, and negative 2.2 divided by negative 0.2 is 11. Now I have a nice trinomial. I can crisscross. X times x is x squared. 11 times 1 is 11, but I need my check to be negative 12, so I'll put a double negative there so that I have negative 11x, negative 1x, and together that does give us the negative 12x. So that leaves us with 0 equals the GCF, that's not disappearing, x minus 11, x minus 1. And then when I branch out to solve, I will be left with x equals positive 11 when that negative 11 moves over, and x equals positive 1. Now, x represents the number of fidget spinners in thousands. So I'm not selling 1 or 11 fidget spinners, I'm selling 1,000, 11,000 fidget spinners. And that's what I'm going to write in my therefore statement. So therefore, you must sell 1,000 or 11,000 spinners to break even. And looking at the visual here, anything in between 1,000 and 11,000 will be making a profit. So that's the happy spot in this scenario. I'm just going to label those zeros on my graph in case I need them later on. All right. How many fidget spinners must be sold to reach a maximum profit? The minute I see the word maximum, we should be thinking vertex. And if we have the zeros, we know that the vertex has to be halfway between those zeros. So I'm going to start off by finding that axis of symmetry by adding my x's and dividing by 2 to get to that middle number. So we get 12 over 2, which is 6. And x represents the number of fidget spinners, so we did just answer the question, but again, in thousands. So therefore, 6,000 spinners need to be sold for a max profit. And what is the maximum profit? Well, if we know how many spinners need to be sold, let's just replace x with that number. Now, we're not plugging in 6,000, we're just going to plug in that 6 because x is in thousands anyway. So negative 0.2 times 6 squared plus 2.4 times 6 minus 2.2. Now, I put it into the standard form. I could have, of course, easily put it into my factored form as well. Either way, when we punch this into our calculator, simplify, we should get 5. Again, that does not mean $5. That would be terrible. Our profit is in thousands, so it's 5,000. Therefore, the max profit is $5,000. All right, let's see what else. How many fidget spinners need to be sold to make a profit more than 1,800? Okay, I'm gonna go back to my sketch here. I would like to label my vertex first. So 6,000 spinners and 5,000 for the max. Now we're asked about this 1,800. So that's under 5,000, so we're asked somewhere here. We're trying to find these points, and anything in between will be more than 1,800. Now, we are given a value for the profit, so I will be replacing P with a number, but it won't be 1,800 because P is the profit in thousands. So I'm going to divide this number by 1,000 to get 1.8 because 1,800 represents 1.8 in the equation. So we're going to have 1.8 equals, and I'm going to go into my standard form. I can't use my factored form anymore. And now, unlike when we were solving for the zeros, one side isn't equal to 0, so we can't factor just yet. I'm going to bring the 1.8 over, and it will be minus 1.8, so that we're left with 0 equals negative 0.2x squared plus 2.4x minus 4. And then again, we will factor. I'm going to do a common factor. Negative 0.2 still works, so I have x squared minus 12x plus 20. Be careful with your signs here because we are dividing out a negative. And when I crisscross, x times x, I could have 5 times 4, 10 times 2. I think 10 times 2 is my best option, making both of them negative for the check to work, because we'll have negative 10x, negative 2x. That does add up to the negative 12x we need. So here we go. Again, remembering my GCF and then my brackets. And when I branch out, we get x equals positive 10 and positive 2. So if we sell between 2,000 and 10,000 spinners, we will make more than 1,800. I'm saying between here because I want more than 1,800. If the question was about an exact profit of 1,800, I would say exactly 2,000 and exactly 10,000 spinners. So therefore, you must sell between 2,000 and 10,000 spinners to make more than $1,800. So that's a pretty full question here. We solved for the zeros, we solved for the vertex, and we solved for another set of points on the parabola. So let's try another example here. We're going to move away from profit and let's look at an area example. And in this one again, I will be giving us the equation. So the area of a rectangular slab can be modeled by the equation A equals x squared minus 3x minus 14, where x is the length in centimeters of the rectangle. What length will make the area equal to 40 centimeters squared? So this 40 centimeters squared is area, which is A. So we are just replacing A with that number and just doing that one little swap, and we can forget this word problem ever existed, and this just becomes a solve the quadratic equation question. One side has to be 0, so I'm going to bring the 40 over, we're going to subtract it, and now we have 0 equals x squared minus 3x minus 54, and another crisscross. X times x, one of my numbers will have to be negative, so I'm going to do 9 and 6. Because my check has to be negative, I'll make the 9 negative, so that we have a negative 9x, positive 6x. That works beautifully. And we have 0 equals x minus 9 times x plus 6. And when I branch out, I get x equals positive 9 when that negative 9 moves over, and x equals negative 6. Now, going back and rereading the question, x represents the length in centimeters. It does not make sense for us to have a negative value for the length. So we call this inadmissible. So therefore, a length of 9 centimeters will result in an area of 40 centimeters squared. All right, let's try some examples where we're not given the equation and we have to come up with it on our own. So two numbers have a sum of 21. Their product is 68. What are the numbers? So first thing, we need some variables. And the question usually has the variables we need. We need to know what the two numbers are. Those are going to be my two let statements. So let x represent first number. Let y represent second number. And now I'm going to reread my statements and come up with an equation for each. So first, two numbers have a sum of 21. That means addition. So if I add x and y, I will get 21. This is definitely not quadratic, but maybe it'll be useful later on. The other statement is that the product, meaning multiplication, is 68. So if I multiply x and y, I get 68. This is also not quadratic yet, but there is multiplication, so there is potential for this to be quadratic. So what I'm going to do is go back to our substitution knowledge. I'm going to sub this first equation into this quadratic one, or potentially quadratic one, but I can't just yet. I have to isolate for a variable. So I'm going to bring the x over to the other side to isolate for y. I could have isolated for x if I wanted to. And now 21 minus x will go in for y, because that is what y is equal to. And we have x bracket 21 minus x equals 68. And here we are, this is quadratic now. The fact that there was multiplication between x and y gave us potential for quadratic, because now if I distribute this x in, the minute I do x times x, I'll get that x squared that we want. So x times 21 is 21x, x times negative x is negative x squared, and then equals 68. This now just becomes a solving equation question. We're trying to find the numbers. One of the numbers is x, so let's solve for x. I need one side to be equal to 0. I'm just going to bring this over to the other side so that the x squared becomes positive. So x squared minus 21x plus 68. And now a little bit of crisscross. X times x. Try some combinations. Divide 68 by various numbers, trying to find the right ones. And if we try 17 times 4, that will multiply to positive 68, but I need my check to be negative, so two negatives. Negative 17x, negative 4x, that does add up to the negative 21 that we need. So we have 0 equals x minus 17, x minus 4. And now I'm going to branch out. X equals 17, x equals 4. Now please keep in mind, x represents the first number. So x can be 17 or the first number can be 4. So these are two different scenarios. So if my first number is 17, I need to also find my second number, which is y, and we have this nice equation right here that will help us find y. Y equals 21 minus whatever x is. 21 minus 17 is 4. 21 minus 4 is 17. So actually these two scenarios end up being the same thing. The two numbers are 4 and 17. And we can always check our work. 4 plus 17 is 21. Okay, that satisfies the first part. 17 times 4 is 68. Great, I know this is correct, and I've done it algebraically with our knowledge of quadratic equations. All right, Let's try another number related question. This one we're only going to set it up because the solving is very repetitive. We're just bringing everything over, getting it into that standard form, and then factoring to solve. So this time we have two consecutive numbers that have a product of 728. What are the numbers? Okay, so what are the numbers? That's going to be my let statement. Let x represent first number. Now, I'm not going to use y for the second number because I have some specific information in the wording that the numbers are consecutive. So consecutive numbers are something like 2, 3, 4. They're numbers right after another. And to go from one number to the next, we're just consistently adding 1. So if my first number is x, the next one would be x plus 1. The one after that, to go from the first to the second, we've added 2, so x plus 2. And so on. Now, be careful with wording. Sometimes you might have consecutive, let's say, odd. So something like 3, 5, 7. Those are consecutive odd integers. And this time, we're adding 2 to go from number to number. So in that case, we would have x, then x plus 2, then x plus 4, and so on. And that would apply to even as well. But anywho, here we have two consecutive numbers. So if x is my first number, I'm going to let x plus 1, the next one right after, represent the second number. Okay, we've dealt with consecutive, great. Now we need to deal with product. So if I multiply these two numbers, and the two numbers are x and x plus 1, I should get 728. So x times x plus 1 equals 728. That's a quadratic equation. I'm just going to clean it up to get to the point where I would solve. So I'm going to distribute the x in and bring the 728 over. X times x is x squared. X times 1 is 1x. And when I bring 728 over, it becomes negative. And from here, we would factor to find those numbers. All right, and final example for this video. Calculators are sold to students for $20 each. 300 students are willing to buy them at that price. Okay, I'm just going to make a little note here. So for $20, we have 300 students. For every $5 increase in price, there are 30 fewer students willing to buy the calculator. So if I increase my price by $5, I'm going to lose 30 students. What selling price will produce the maximum revenue, and what will the maximum revenue be? So, a few things. Number one, I see the word maximum, thinking vertex. I see this word revenue. Revenue is when you take the price and multiply it by quantity. So in this case, the price times the number of students that will buy this calculator. Now, originally we're given this $20 and 300 students, so if we do 20 times 300, that's $6,000 for the revenue. Not bad. But maybe if we increase the price, bigger price, yes, we're going to have fewer students, but maybe that will give us more money. Or alternately, maybe we drop the price a little bit, get more students buying to maximize. We don't know what the best scenario is here. Now, let's just visualize what this information means. So for $20, we have 30 students. Let's increase the price one time. One increase. One increase will result in $25 for the calculators, 20 plus 5, and 30 minus 30, so $270 for the students. If I have two increases, now it's 20 plus 5 two times, so now we're at $30, and 300 minus 30 two times, so 300 minus 60, which is $240. On my third increase, I've now gone to $35. I've taken the 20 and I've added 5 3 times. And we take 300 and we subtract 30 3 times to take us to 210. This here is our equation. We can get an expression for price and quantity based on how many increases we use. So I'm going to have a variable. Let x represent the number of price increases. It's not what the price is, it's not what the students are. X is the number of times I increase the price. With this, I can come up with both price and number of students. And I'm also going to use R for revenue. Alright, so revenue is going to equal price times quantity. Well, look at how we found the equation. We took the original price and we added 5 however many times we were going to increase, and we're increasing X times. So 20 plus 5 times the number of increases. I increased 10 times, I'm going to do 5 times 10. I'm increasing the price by $50. So I'm adding that on to 20. Then we start with 300 students and we drop by 30 X times. So we have like 2 little linear brackets here. Okay, now we're ready. We need to find the vertex. This is in factored form. So if it's in factored form, that means we can grab the zeros really quickly and then find that middle number. Now to find the zeros, I'm going to communicate nicely by setting my revenue equal to 0 first. And now I'm going to branch out. Here I'm not going to do my shortcut to solve for x because we do have to rearrange these equations because there is a coefficient in front of the x other than 1. So bring the 20 over, it becomes negative, divide out the 5, and we get x equals -4. So this isn't anything about the maximum revenue. This just means if I drop my price 4 times, so dropped because it's negative, then I'm going to get a revenue of 0. So that's definitely not ideal. I'm going to do it for the other bracket. Bring the 300 over, turns negative, which is okay because I'm going to be dividing out a negative here. And I get x equals 10. So if I increase the price 10 times or drop the price 4 times, my revenue will be 0. Either because the price will be $0 or because I get 0 students buying these calculators. And 0 times anything is 0. But my goal is vertex. The vertex has to be in the middle of these 2 numbers. Okay, because if we were to do a little sketch here, those would be the x-intercepts. So xv is -4 plus 10 divided by 2, which is 6 divided by 2, which is 3. So that means I need 3 increases to maximize the revenue. So now I'm going to go to my revenue equation, 20 plus 5 times the 3, and 300 minus 30 times the 3. And I'm not going to punch this into my calculator all in one go because each bracket has meaning to me. 20 plus 15 here is 35. So there's my price. And 300 minus 90 is 210. So that's the quantity, the number of calculators I'm selling. And now I can multiply 35 times 210 and get a revenue of $7,350. Now going back to my question here, it said what is the selling price that will maximize the revenue and what is that maximum revenue going to be? So in my therefore statement, there's my price, there's my max revenue. So therefore, a price of $35 per calculator will give a max revenue of $7,350. And there we are. Here are some applications, some where we were given the equations and some where we had to come up with them on our own. And in the questions, we're just looking for those keywords that tell us whether we're solving for zeros, for the vertex, for a random point on the parabola. And that's it.